Assalamualaikum warahmatullahi wabarakatuh. My name is Fitri Permadani from TT42 INT. In this video, I will present my major assignments in designing the antenna. So the antenna that I will design is the microstrip single rectangular that working on frequency of 2.4 GHz. Here is the antenna specifications that I use. For working frequency, it is in the range of 1.4 until 3.4 GHz. For the center frequency, it is 2.4 GHz. The FSWR is less than or equal to 2. The gain is more than or equal to 3 dBi. The polarization is linear. The input impedance is 50 ohm. And the return loss is less than or equal to negative 9.54 dB. And here is the table for the parameter before the optimizations. We can see here that there are 10 parameters. This parameter is already calculated manually, and those calculation is in the report. So the H is the substrate thickness, which is the 1.6. The T is conductor thickness, it is 0.035. Next is LP, which is the patch length, 27.094. WP is the patch width, it is 37.3. LF is for fit line length, it is 15.07. Next is the WF, which is the fit line width, it is 4.85. Next is WG, ground plane width, it is 46.9. And next is LG, it is the ground plane length, it is 36.694. Then next, there is X0, which is the 6.14, and W0, it is the 8.25. And here is the parameter after the optimizations. So because in the first simulations, the result is not good enough, so I did the optimizations to get the expected result. So there's the changes in the parameter values, which is the LP and the WP. The LP is changes to 29.803, and for the WP, it changes to 33.598. So here is the antenna that I designed. This is the front view. We can see I already give the number. The number 1 is the ground plane width. Number 2 is the ground plane length. Number 3 is the patch width. Number 4 is the patch length. Number 5 is the inset fit length. Number 6 is the inset fit width. Number 7 is the fit line width, and the number 8 is the fit line length. This parameter is already through the calculation sections. Next is the side view antenna design. So this is the side view of my antenna design. The parameter is the first one. There is T. There is T, which is the conductor height. It is 0.035. Next is H, which is the substrate height. It is the 1.6. Then after we running the simulations, we got some antenna performance parameters. The first one is the return loss. We can see from this graphic that the red one is the result from before the optimizations, and the green one is after the optimizations. So I can conclude that the results is already fulfill the requirements of the antenna eligibility, because a good return loss value is less than or equal to negative 9.54, while I get the negative 11.58. Next is the bandwidth. So the left one is the bandwidth before the optimizations, and the right one is the bandwidth after the optimizations. So we can see that in the before optimizations, the graph is really bad. I mean, I cannot see the curve of the line, so I cannot determine the bandwidth value. Meanwhile, after optimizations, I got the curve of the line, and I can determine the bandwidth value. And using the calculation, So it becomes the 104 megahertz. The next is FSWR. So the red one is the result before the optimizations, and the green one is the result after the optimizations. So we can see that this is really so far away before and after the optimizations. After the optimizations, the result is fulfill the requirements of antenna eligibility for FSWR because the good FSWR is less than or equal to 2. Next is Jane. The left one is before optimizations, and the result is 4.97 dBi, and the right one is the after optimizations, the result is 5.24 dBi. Before and after optimizations, the Jane is already fulfill the antenna specifications for the Jane because the antenna specification for the Jane is minimum 3 dBi. So we're here up to the conclusions. For the conclusions here, I use the antenna performance comparison before and after optimization. So you can see from the table, I compare the value of the parameter result before and after optimizations. And I can conclude that this antenna design works well in the frequency of 2448 megahertz, which is it is good because all the performance value is fulfill the requirements of antenna eligibility. So after this, I will show you my simulation result in CST. So after I get all the parameters that I already showed before in the slides from the calculation sections, so I just need to do the simulation using the CST. So here is my complete antenna. But first, when do the design, we have to input all the parameters value in the parameter list below here. So I already put it all. And then after that, we just need to design one by one the components. So here I have the ground plane, the page, and the substrate. And also the insert feed and the feed line. But why the insert feed and feed line do not show here? It is because they already combined to the page. To make the component, we just move to the modeling, then brick, and then click ESC, and this box will show, and you just need to set all the parameters and define one by one the component. After that, don't forget to make the port. For a port, we need to do first we need to pick phase in the feed line width. After that, we just move to the home, to the macros, to the solver, and then to the ports. After that, in the calculate port extension coefficient. So here, to set the port. After that, just doing the simulations, which is just click this start simulations. And then just waiting until the process done. After that, the result will show. So because this is my complete design, my complete simulations, so I already do the optimizations. So before doing the optimizations, I got the result for the VSWR and for the S parameter, which is the return loss, is worst. I mean, it is bad because it is not fulfill the requirements of the eligible antenna. But after I'm doing the optimizations, I got the better result. So you can see that this is my S parameter, which is the return loss. In the working frequency of 2.4, we can see here that the return loss is negative 11.58. This is indicate goods. Why? Because the requirement of the return loss should be less than negative 10 dB. Because I already got it less than negative 10 dB, so we can indicate that this is the good parameter, the good result of the return loss. And then next is FSWR. We can see here in the working frequency of 2.4, I got the 1.7s. That is indicate as the good result because the FSWR that good must be less than or equal to 2. And then for the far field, which is the gain, I got the 5.24 dBi, which is good because the specifications of the antenna that I choose must be minimum 3 dB because this is already above the 3 dBi, so I can indicate that this is the good chain. And that's all. And last, I will show you my complete design first. So this is the front view, this is the side view, this is the back view. Yeah, that's all. So that's all for the simulations. Thank you.